Hey guys, haven't seen you in a while, some of you, so I hope all is going well and you're making the best out of the situation. This is going to be video one dealing with probability. This is what we're going to be working on for pretty much the remainder of the year. So, probability, basically, we got to start with what it is. So, probability is basically a ratio, fraction, however you want to do it as percent, of favorable outcomes over all possible outcomes. And it can be anything. It can be flipping a coin, rolling a die, picking the lottery numbers, whatever it is. In the first unit we do, they distinguish between two, theoretical and experimental. Theoretical basically is based upon what you know. For example, flipping a coin. The probability of getting a heads is 1/2. Probability of getting a tails is 1/2. All right. Probability of anything else is 0. Experimental is based upon what you're actually doing. So, for example, if we flip a coin, all right, 8 times and we get 3 heads, 5 tails, all right, the probability of getting a heads, if we're doing it theoretically, this is ignored. So that would be 1/2. All right, but experimental is based upon what we do. So the probability of getting a heads experimentally, since we have 3 heads, 3 plus 5 is 8. So the probability of getting it, and the experimental probability would be 3 out of 8. All right. The next thing we're going to discuss is the handout that came attached to today's message. All right. So we're looking at these problems to help go through this. So number 1 says, what is the probability of rolling a number greater than 2 on a number cube? Okay, a number cube's a lot like a die. There's 6 sides on it with the numbers 1, 2, 3, 4, 5, 6. All right, so basically all you have to do is think to yourself, how many numbers are greater than 2? So that would be 3, 4, 5, and 6. So that's 4 of them. So the favorable outcomes would be one of these, so that's 4, over the total number. Since there's 6 sides, that would be 6. 4 over 6 reduces down to 2/3. So your answer would be D as in delicious. Okay, now number 2, a coin flip, and you got to read carefully. It says a coin is tossed 30 times and lands on heads 17 times. What is the experimental probability of a coin landing on it in italics tails? Okay, so they flip it 30 times, it's 17 heads. It means it's got to be 13 tails. Experimental is based upon what we've already done. So the probability of tails would be the total number of favorable outcomes, the tails, which is 13, over the total number of times we flip the coin, which is 30. 13 over 30 matches up with H's in Hawaii. So the answer to that one would be H. Number 3, it says, what is the theoretical probability of randomly choosing a science book from a shelf that holds 3 mystery books, 5 science books, and 4 nature books? All right, well, now we're dealing with theoretical. So we're based on the information they give us, not what people chose or anything like that. And they want to know what's the probability of a science. Well, we look at how many science they give us, which is 5, over the total number of books. 3 plus 5 is 8, 8 plus 4 is 12, 5 over 12. Again, we're assuming there's no bias. So we're assuming that someone isn't predisposed to take a mystery book or a nature book or anything like that. All right. Now, next up, number 4. All right. Number 4 is a vocab word, a complement. Basically, if probability is favorable outcomes over total outcomes, the complement would be the unfavorable outcomes. So it says, what is the complement of rolling a 2 or 5 on a number cube? So we go back to the cube. Numbers 1, 2, 3, 4, 5, and 6. So the complement is the unfavorable, so we cross out the 2 and 5, and what's left? 1, 3, 4, 6. That makes up our complement, which is G as in giraffe. All right, and the last one, the short response, it says number 5, a spinner has 4 equal sections labeled 2, 4, 6, and 8. Suppose you spin the spinner twice. What is the theoretical probability that the sum of the outcomes is 10? Show the favorable outcomes. All right, so we're going to use a tree diagram. There's 4 possible numbers we can spin, 2, 4, 6, and 8, and they're all the same. Later we'll deal with different sizes and that kind of thing in terms of probability. But right now they're all the same, so it's an equal probability of all of that. So on our first spin, we could get a 2, 4, 6, or 8. On our second spin, we could get any one of those numbers, so we list them. Then all you do is add them. 2 plus 2, 4. Great number, but not 10. Same thing moving down. 2 plus 4, 6. 2 plus 6, 8. All right. 2 plus 8 is 10. We got a winner. All right. 4 plus 2 is 6. 4 plus 4 is 8. 4 plus 6, 10. We got another winner. If you recognize the pattern and realize 1 out of every 4 is going to be a winner, that's fine. If not, Here's the remainder of the tree diagram. 6 and 2, 6 and 4. Oh, there's our winner. 6 and 6, 6 and 8. Again, we're looking for one to match up to 10, and then 8 and 2 is 10. All right, so how many total up to 10? 4 out of how many possibilities? Well, there was 4 possibilities in the first one. We'll deal with this later in the unit with fundamental counting principle. 4 possibilities for the second one. 4 times 4 is 16, but that's labeled out here. 4 out of 16 reduces down to 1/4. So basically our answer would be 1/4. And if it asks you to, it says show the favorable outcomes, that'd be 2 and 8, 4 and 6, 6 and 4, 8 and 2. Hope it helped, guys. Be good.